Cheesemaking is extremely sensitive to milk quality like no other milk processing technology. There is even a special technical term of cheesemaking, friendly milk. That is, the milk containing the optimal proportion of protein and fat. Also, the raw material should be eco-friendly, with no chemical and biological contamination. That is the reason why all cheesemaking plants are located far from big cities. The way from milk to the finished product starts in such huge cheese-making 6,000-ton cheese vats. The yield of each vat will be 1,323 pounds of cheese. But first, the farmer's milk passes through a number of thorough lab analyses. After that, it should be pasteurized to kill all harmful microorganisms and bacteria. Ivan, if I understand it, right there is just milk in that huge cheese vat, and I guess it was brought directly from a dairy farm.
This milk has passed through a normalization and pasteurization between the temperature of 172 to 176 degrees Fahrenheit. After that, it was chilled down to the temperature of inoculation.
As soon as a cheesemaker gets rid of some bacteria through pasteurization, he adds a new one, a special fermentation starter. It is a solution of germ culture which is poured in through a separate pipeline. This is how the cheesemaking process starts. Mesophilic bacteria are mainly used for making semi-hard varieties of cheese. These microorganisms make cheese as we know it.
What do we need them for? We need them for generating ferments during their life-sustaining activity, which split milk protein and milk fat. That way, cheese flavor, aroma, and texture are formed.
The milk with the starter is heated to 89.6 degrees Fahrenheit, which is the optimal temperature for mesophilic streptococci propagation. However, milk will never turn into cheese only with the help of bacteria and temperature. We need to add a catalytic agent, which will accelerate the speed of curd formation. That agent is called enzyme rennet. It breaks down the structure of casein molecules and makes milk change its state from liquid to gel.
After adding the enzyme rennet, we stir it for 5 minutes, not more, and leave it as it is. We need to leave it as is, otherwise the curd can be destroyed.
Well, right here in the cheese vat.
That is some of the mechanical changes that can happen to the curd.
In that cheese vat, it will remain for a while, as if to rest.
Yeah, that is for when we, yes indeed, when we add the enzyme rennet, we stir it and leave it as it is. At that very moment, it starts coagulating milk, and let's say milk protein or casein is being turned into insoluble condition. Okay, curd has been formed. The supervisor will check it, cut the curd, and take a sample. If nothing is wrong, we can continue the process. To cut, you will see how granular curds and whey are formed. All that stuff, you know.
Oh yes, let's try it then.
Here she is lifting the cut. Curds has been formed and its edges are sharp and even. Okay, we can start cutting it. We have lifted it up and saw its structure. That is, its sharp edges.
Is it dense?
Yes, yes, yes.
And what then? Can we switch on the curd breaker again?
Yes, we will switch them on starting from a lower speed, then the speed will be increased. That is, I mean cutting of curds. And later we will see how the granular curds are formed.
Both bacteria and the enzyme rennet need several hours to separate the milk to a liquid fraction and granular curds. By the way, if we stop the process at that stage, we will get some cottage cheese. However, today's program is about a regular cheese. Okay, it's molding time. The granular curd from the cheese vats is sent along pipelines to those rotating drums. Right now we need to distribute it evenly and put the curd into those cylindrical molds. My hands are clean as I have just washed them, so I can take part in the process. What shall I do?
We're going to start filling in the molds now.
Okay, can I pour the curd in?
Sure.
Very pleasant to touch indeed. That granular substance is something soft and warm. Up to the brim.
Up to the brim, yes. We have to fill in the molds completely, and then we'll make some sort of hills. And now like a hut.
Ah, that is some more on the top.
Yes, and then evenly distribute everything.
That way, like a pie.
Yes, sure.
And that top, shall it be big?
No, that's enough. Now let me carry it away. And let me bring another set of molds.
When the cheese to be was distributed among the molds, the granular curd should be pressed. To do that, the semi-finished cheese is sent to stay under press for 12 hours. That time is used to remove extra liquid and the cheese takes its regular shape. Calcium chloride, a special additive, is added to increase the granular grain density.
We add calcium chloride to the cheese vat. We do it to increase the concentration in milk, which is important when the curd is being formed, as calcium bridges improve the curd density and the granular curds as well. If we don't add calcium chloride, we do not achieve the required curd density.
The cheese spent the entire night under press and became firm and heavy. It weighs about 22 pounds. Right now, we have to work hard to take it out of the mold. Careful.
Well done.
Great.
On the first try.
What shall I do after that?
Then we shall turn the block over and remove the cheese from the cheesecloth.
Okay.
Great. Then we need to take a knife and cut off all the extra pieces from the
Okay,
egg.
this one should be cut off. Great.
Yeah, you see, you're doing a great job.
Yeah, I'm trying to.
Well done. Come on, don't be shy. Great.
I'm just afraid to cut off anything extra. Well, I mean to cut a lot.
Now we put it into the container.
And here it is. Almost full. Is it a container, huh?
And it is the container which will be sent to the brine vat.
Okay.
And then it will be salted there.
In the vat.
Yes, in the vat.
For a swim or a bath.
To swim.
Okay, let's go. Color intensity depends on the variety and technology of cheese making. Intense yellow color of semi-hard and hard varieties tells about its high quality and compliance to the technological requirements. That is why some manufacturers add a little of coloring agent to the finished cheese. Cheese especially needs adding a coloring agent in the fall and in winter, when cows usually never eat green grass.
The coloring agent is typically added to milk in the off-season. I mean, milk is good in May. There are plenty of dandelions in the fields, so milk is yellow that time. The customers believe that the yellowish milk is a higher concentration of fat, and that means that it is more natural. So we must add some coloring agent.
E160B annatto is the most commonly used cheese coloring agent. To find out how they make the cheese, which is spread over a piece of bread rather than put on top of it, you need to go to a different plant. The technology of cheese spread making differs from making semi-hard cheese significantly.
There can be several varieties of that cheese, including Gouda, Russian, Dutch, and so on.
Cheese spread is made of semi-hard varieties. Their mixture is added to a kettle to mix and to melt. Note that cheese is not the only ingredient, as butter and different white powders are added there as well.
Right now, butter and Edemeyer cheese are being loaded into the melting kettle. After that, a milk powder and cheese melting salt will be manually added there as well.
Cheese melting salt is a common name for the food additives which trigger protein dissolving and homogeneous spread of fat along the entire stuff. The most popular ingredient of that type is E452 polyphosphates.
Cheese melting salt is sodium monopolyphosphates. They must be added as they influence the formation of cheese crystal lattice. Two kinds of cheese melted salt are used for making the triangle cheese spread. One type of salt is responsible for the cheese spread consistency, whereas the second one is in charge of the non-adhesion of the cheese spread to the foil. Very little of it needs to be added. The cheese spread looks like an omelet without adding a cheese melting salt. Probably everyone knows the typical omelet structure, or the broken consistency including flakes, small pieces, and unmelted parts.
After adding all the ingredients, the kettle is closed, vapor is automatically sent there, and the mixture inside is heated to 194 degrees Fahrenheit. After that, the cheese spread to be comes through the secondary thermos treatment at 284 degrees Fahrenheit to completely exclude the presence of any harmful microorganisms. However, that higher temperature kills not only harmful but useful and living microorganisms, which are used as a fermentation starter for making semi-hard cheese. That is why cheese spread is considered dead. So, we come back to the production site of semi-hard cheese. It has spent 2 days in the brine. Now it is going to be sent to the drying and ripening chamber, where microbiological processes determined by bacteria life-sustaining activity goes on. It is a well-known fact that the time of cheese and wine aging determines its quality and price. Packaging is the final stage of cheese production. A block of cheese is wrapped into a special film which, like human skin, protects from damage, but allows it to breathe.
Special film has special functions. It allows carbon dioxide to go out and block oxygen intake. What do we need it for? Mold and yeast, which can be on the block of cheese surfaces, can survive only with oxygen. No oxygen, no life, no mold, no yeast.
Okay, the cheesemaker's hard day is almost over. The plant produces 14 to 15 tons of semi-hard cheese per day. I guess that today's batch will be some 20 pounds lighter. It's a gift for me, and it's free.